laws today, and we're going to do law of sines right now, which starts off very similar to the law of cosines. However, the goal here in the law of sines is different. Remember, in the law of cosines, the goal is to find any side or any angle of a triangle given three pieces of information. In the law of sines, our goal here is to find area of any triangle, not just a right triangle. Okay, so same idea though. We have angles A, B, and C, and sides sides A, B, and C. Again, just because it's over in the corner here, I'm going to use angle C as my point of reference. In other words, what I mean by that is when I'm doing my right triangle trigonometry, right, SOHCAHTOA, I'm going to be referencing angle C so I know what is opposite, what is adjacent, and what is hypotenuse. Okay, and I'm going to drop a perpendicular down here again. I'm going to call this H, and I'm going to solve for H, knowing that that is opposite angle C and A is adjacent to angle C. So if I'm talking opposite and adjacent, that is the so. So I have, opposite and hypotenuse is so. So sine of C is opposite over hypotenuse. In other words, A sine of C is my height. Likewise, if I wanted to, and this is where the law of cosines takes over, I could find this by using k, the adjacent and the hypotenuse. But I've gone far enough here as far as area is concerned. We know area of a triangle is 1/2 base times height. Okay, so the area is 1/2 B times A sine C, right? That is my height. All right, and notice A, B, and C are side, angle, side situation. All right, and we're searching for area here. So again, it is conceivable you could be given area and sides A and B, and you could find the included angle, right? The angle that is between the two sides. It's conceivable you could be given the area, side A and side C, and you could find the other adjacent side. All right, so in other words, a side angle side situation is what applies here, where the law of cosines, you're given anything. Side angle side is the easiest situation because that's the formula set up to find the third side. But you can find a lot more in the law of cosines, whereas the law of sines, strictly side angle side and area. So that is the law of sines. I'm just going to add on to this a little bit, just like with the law of cosines. I started with C as my point of reference. If I change my point of reference to A, okay, look at how this is going to change. Instead of having A, B, and sine C, I'm going to have B, C, and sine of A. And if I change my point of reference to angle B, I'm going to have A, C, sine of B. Okay, so again, they're all side angle side situations. If you look closely, angle A is surrounded by sides B and C. And here, angle B is surrounded by sides A and C. So they're all side angle side situations. One last piece to the law of sines here. These are all areas of the same triangle using a different angle as a point of reference. So it stands to reason that all three of these should be equal to each other. And it stands to reason if these three are equal to each other, and the fact that sides A and B and C are actual lengths, in other words, are never equal to 0, I can take this whole thing and divide it by the same value. I'm going to do 1/2 ABC, 1/2 ABC, 1/2 ABC, and they should all still be equal to each other, correct? Let's see what happens. 1/2, 1/2. A and B go, A and B go. Half, half, B and C, B and C. Half, half, A and C, A and C. And I get sine of C over C equals sine of A over A. equals the sine of B over B. All right, so while this is what our book will officially tell you is the law of sines, law of sines, note that it is derived from a simple area formula dealing with sine. Okay, so two little pieces here getting to the law of sines. The sine of an angle over its side is equal to the sine of another angle over its side. Okay, so this equation, you're really going to use two pieces at a time. It could be the C piece with the A piece. It could be the C piece with the B piece. It could be the A piece with the B piece. All right, so yes, I know this is three different entities here, but you're using two at a time typically to solve this. Okay, you don't need all three of them there. All right, I hope that clears things up with the law of sines. We'll be back later.